Get this. Researchers are using video games to train AI.
Oh, really?
Yeah, like simplified versions of Super Mario.
Huh. Interesting.
It sounds crazy, right? Like something out of science fiction.
Yeah, it does.
But it's a real area of research with some pretty big implications.
I can imagine.
So what's so cool about this?
Well, these virtual worlds,
Yeah.
they provide a safe and controlled space for the AI to learn and to experiment.
Okay.
So like a giant sandbox
Wow.
where the AI can try different strategies and learn from mistakes
I like that.
without causing any real-world harm, you know?
That's a great analogy.
Yeah.
Yeah, it's like giving a toddler a set of building blocks.
Right.
You know, they can experiment with different combinations.
Sure.
Learn about gravity.
Yep.
Develop their spatial reasoning.
All within a safe environment.
Exactly.
Yeah.
And in this deep dive, we're going to explore a paper
Okay.
from researchers at INSATE
Okay.
and Sophia University,
Uh-huh.
St. Clement Oridsky, who are developing these world models, which are AI systems that can learn the rules of a virtual environment
Okay.
and predict what will happen next.
Got it.
So it's like teaching AI to understand cause and effect.
Yeah, you could say that.
Like if I jump on this platform,
Okay.
I'll bounce higher.
Right.
If I miss that jump,
Yeah.
I'll fall into a pit.
Exactly. That kind of thing.
Okay.
Yeah.
These models learn to anticipate the consequences of their actions
Right.
within the virtual world.
Yes.
And the exciting part is
What's that?
these skills could potentially be transferred to real-world scenarios.
That's the idea.
Now, that's where it gets really interesting.
It does.
So we're not just talking about AI beating us at Super Mario,
No.
but AI that could,
Okay.
say, navigate a self-driving car through a city.
Exactly.
Wow.
Yeah.
The researchers in this paper developed two new models
Okay.
called GenieRedux and GenieRedux-G,
Interesting.
which build upon a previous model called Genie. Okay, so let's unpack these new models.
All right.
What makes them so special compared to the original Genie?
Well, one of the key challenges with training AI is the sheer amount of data required.
Okay.
Imagine having
that?
to record hours and hours of gameplay footage
Oh,
just to teach an AI the basics of
Yeah.
a simple game.
I see.
That's where GenieRedux and GenieRedux-G come in.
Okay.
They use a clever technique
Okay.
to make the learning process more efficient.
Okay, I'm all ears.
Yeah.
Tell me, how do they streamline this data-hungry process?
Instead of relying solely on human gameplay data,
Right.
they use a trained agent,
Okay.
essentially an AI that's already learned to play the game well.
So it's like having a star student
Exactly.
who can tutor the model.
You got it.
So the learning process is much faster,
Yeah.
more effective.
That's right.
So instead of watching countless hours of beginner-level gameplay,
Uh-huh.
the model gets to learn from an expert from the get-go.
Exactly.
That's brilliant.
Yeah.
And what's even more remarkable,
Tell me.
GenieRedux-G takes this a step further.
Okay.
It bypasses the need for the model to predict the actions of the trained agent, and instead uses the agent's actions to directly predict the next frame in the game.
Wow.
So it's like the model is looking over the shoulder of the expert
Uh-huh.
and directly learning from their every move.
Yeah.
It's cutting out the middleman,
Right.
which makes the learning process even more streamlined and efficient.
Precisely.
And to test these models,
Okay.
the researchers used a game called Coin Run. Think of it as a minimalist version of Super Mario,
Okay.
designed to be easy for AI to understand.
Right.
It involves a character running and jumping to collect coins while avoiding obstacles.
A classic platformer.
Yeah.
Perfect for testing an AI.
So what happened when they set these models loose in Coin Run?
Well,
Did they manage to collect those virtual coins?
they did, and with impressive results.
Tell me more.
They trained the models using data from both a random agent,
Okay.
which is basically pushing buttons haphazardly,
Right.
and a trained agent.
Okay, so our expert player.
Exactly.
Okay.
And the models trained on the trained agent's data
Yeah.
were significantly better at predicting future frames in the game
It's interesting.
and could even perform specific actions on command, like jumping or
Yeah.
moving left or right.
It's like comparing a student who's been cramming all night
Yeah.
to one who's had consistent tutoring
Uh-huh.
from a top-notch teacher.
Right.
The difference in performance is bound to be significant.
Exactly.
And to measure this performance,
Okay.
the researchers used several key metrics,
Mm.
kind of like a scorecard for AI abilities.
Okay.
I'm always fascinated by these metrics.
Yeah.
Yeah.
Mm-hmm.
They can sometimes feel a bit like alphabet soup.
I know what you mean.
But I know they hold the key to understanding how well these models are performing.
Right.
So walk me through these metrics. What are we looking at here?
Well, one key metric is FID,
Okay.
or Fréchet inception distance.
Okay.
It essentially measures how realistic the images generated by the model are compared to real images from the game.
So think of it like a painting competition.
Right.
Where the judges are comparing a copy to the original.
Exactly.
The closer the copy resembles the original, the lower the FID score.
You got it.
So a lower FID score means the AI is creating images that are practically indistinguishable from the real game.
That's right.
That's pretty impressive.
It is.
But visual fidelity is just one aspect.
Right.
We also need to consider how well the model can control actions within the game.
Yeah.
Where another metric comes in.
Okay.
APSNR.
All right, break down APSNR for me.
Yeah.
What's this metric all about?
Well, APSNR measures how well the model can control actions within the game over time.
Okay.
Specifically, how accurately it can predict future frames based on those actions.
So think of it like a choreographer judging a dancer.
Right.
It's not just about the individual moves,
Gotcha.
but how smoothly and accurately they can execute a complex sequence of steps.
So a higher ATPSNR score means the AI can not only predict what will happen next, but can also control the flow of events within the game.
That's right.
That sounds like a crucial skill
Yeah.
for real-world applications.
Yes.
Like self-driving cars,
Right.
where anticipating future events is paramount.
Exactly.
And this is where we see a significant difference
Okay.
between GenieRedux and GenieRedux-G.
Tell me more.
GenieRedux-G, by directly using the actions of the trained agent,
Heck.
achieves significantly higher ATPSNR scores,
Interesting.
particularly when predicting further into the future.
Hmm.
So by learning directly from the expert player,
Yeah.
GenieRedux-G becomes a more skilled and precise
You could say that.
virtual dancer, so to speak.
Right.
Its predictions are more accurate.
Uh-huh.
Its control over the game is enhanced.
Precisely.
And this brings us to another important point. The researchers compared their models to a similar model called Jafar, also based on Genie.
All right.
So we're bringing in another contender to the AI arena.
Right.
What can you tell us about Jafar?
Well, despite being trained with similar parameters, GenieRedux outperformed Jafar in terms of visual fidelity,
Interesting.
achieving significantly better scores on those key metrics we discussed.
So it seems like GenieRedux is emerging as the front runner in this AI showdown,
Yeah, you could say that.
showcasing better visual realism and control over the virtual environment.
That's right.
Compared to Jafar?
You got it.
Wow, this is all very fascinating.
It is.
And I'm sure there's a lot more to unpack here.
There is.
So in the next part of our deep dive,
Yes.
we'll take an even closer look at these metrics,
All right.
exploring the nuances of their performance
Sounds good.
and what they reveal about the potential of these models.
Looking forward to it. Welcome back to our deep dive.
It's amazing to think that these virtual worlds could be the training ground for like the next generation of AI,
Exactly.
powering everything,
Yeah.
from self-driving cars to robots that can assist us.
And we left off talking about GenieRedux and GenieRedux-G.
Right, these models that are showing remarkable progress.
Yes, and their ability to understand and predict events within a virtual environment.
And we were just starting to talk about those key metrics,
Mm-hmm.
like FID,
Yes.
which measures how realistic the images are
Right.
compared to the real game.
FID is all about visual fidelity. Imagine you're looking at two images
Okay.
side by side.
Right.
One generated by AI
Okay.
and the other a screenshot from the game.
Right.
If you can barely tell the difference,
Yeah.
that's a sign of a low FID score, meaning the AI is doing a fantastic job.
So it's like those spot the difference puzzles
Yeah.
where you have to look really closely if the AI is producing images that are that close to the real deal.
It is indeed.
That's impressive.
But visual fidelity is just one piece of the puzzle.
Right.
We also need to consider how well the model can control actions.
Right. We talked about delta TPSNR earlier, which measures how well the model can predict future frames
Yes.
based on its actions in the game.
Right.
Could you elaborate a bit more on why this metric is so crucial,
Certainly.
especially when we're talking about real-world applications?
Think about a self-driving car
Yeah.
navigating a busy intersection.
Yeah.
It needs to not only perceive its surroundings,
Right.
but also predict what other cars and pedestrians might do.
To make safe decisions.
That's where delta TPSNR becomes so relevant.
So a high delta TPSNR score means the AI is becoming like a skilled forecaster,
Precisely.
able to predict the future with a high degree of accuracy.
And this ability to predict future events is not just important for self-driving cars, but for a wide range of applications. Robots that can assist in surgery, AI systems that can manage complex supply chains.
It's like we're moving towards a future where AI can not only understand our world, but also anticipate what's going to happen next.
It's an exciting prospect.
It is.
And the researchers in this paper found that GenieRedux-G, the model that learns directly from the actions of a trained agent, consistently outperformed other models.
Interesting.
Particularly when it came to delta TPSNR.
So it suggests that by learning from an expert, the AI can develop like a more nuanced understanding of cause and effect, leading to more accurate predictions.
Exactly.
It's like having an experienced mentor guiding the AI.
Helping it see those subtle connections.
Right.
And it's not just about predicting what was happen a few frames into the future, but being able to anticipate events further down the line.
Okay.
Think about a chess game.
Right.
A skilled player can think several moves ahead, anticipating their opponent's strategies, planning their own moves accordingly.
Similarly, AI with a high delta TPSNR score can predict the flow of events
further into the future,
giving it a significant advantage.
Precisely.
It's like AI is developing a strategic mindset, able to think beyond the immediate present and anticipate future challenges.
Now, in addition to FID and delta TPSNR, there are a couple of other metrics that provide further insights into the performance.
Okay, I'm all ears.
What other metrics are we looking at?
Well, there's PSNR, or peak signal to noise ratio,
which essentially measures the clarity and fidelity of the images generated by the AI.
So think of it like comparing a high-definition image to a blurry one.
The higher the PSNR, the clearer and more detailed the image.
So a high PSNR score means the AI is producing images that are sharp and crisp and visually appealing.
Exactly.
And then we have SM, or Structural Similarity Index,
which goes a step further than PSNR. By considering not just pixel level differences, but also the overall structural similarity.
So think of it like judging a building based on its architectural integrity rather than just the quality of its bricks.
Precisely.
So a high SM score means the AI is not just replicating pixels, but capturing the essence of the game's visual style.
You got it.
Its overall aesthetic.
And in all of these metrics, GenieRedux and GenieRedux-G demonstrated impressive performance.
Interesting.
Surpassing the original Genie model, showcasing significant advancements.
It's incredible to see how far this technology has come.
It is.
We've been talking about these models being trained on a simplified version of Super Mario called Coin Run. How do you think these models would fare?
That's an excellent question.
If they were unleashed into a more complex game.
And it's one that the researchers acknowledge.
Like the latest open world adventure.
While Coin Run provides a valuable testing ground, they recognize the need to explore how these models perform.
So it's like starting with a basic training course.
Exactly.
Before tackling the advanced obstacle course. Coin Run provides the foundational skills. But the real test lies in how these models adapt
to more complex environments.
Well, I'm eager to see what the future holds for this.
You too.
But let's shift gears a bit.
Okay.
And talk about the potential real-world applications.
All right.
We've touched upon self-driving cars.
Yes.
But I'm sure there are countless other areas.
There are.
Where this technology could make a real impact. Welcome back to the final part of our deep dive. We've been exploring these models that are learning to predict the future.
It's really remarkable how these models trained on simple games like Coin Run are showing promising results. But the real excitement lies in the potential for real-world applications.
Exactly. And we've talked about self-driving cars. But where else do you see these making a real impact?
One area is robotics. Imagine robots that can navigate complex environments, but also anticipate changing conditions. Like a robot in a warehouse that can predict the movements of objects and workers.
So they can avoid collisions.
Exactly.
That would be a game changer for so many industries.
And then there's healthcare.
Oh, wow.
AI systems that can analyze medical images, predict patient outcomes.
Okay.
even assist surgeons.
It's like having an AI doctor by your side.
And the applications go beyond specific industries.
Oh, like what?
These models could be used to improve weather forecasting,
Okay.
manage traffic flow, even create more realistic video games.
Wow, it seems like every aspect of our lives could be touched by this.
It really does.
But as we develop these systems,
Yeah.
it's crucial to address the challenges
You're right.
and make sure they're used responsibly.
Absolutely. As with any powerful technology, there are ethical considerations.
Let's go first.
We need to ensure these models are developed and used in a way that benefits humanity.
It's like giving someone a powerful tool.
Exactly.
You want to make sure they use it wisely.
And one of the key challenges
What's that?
is generalizability.
Okay.
While these models perform well
Yeah.
in virtual environments,
Right.
how well can they adapt to the real world?
It's like teaching someone to swim in a pool.
That's a great analogy.
They might do great there,
Right.
but how will they fare in the open ocean?
And exactly.
Another challenge is data.
Absolutely.
These models are data hungry,
And training them on real-world data can be tricky.
especially sensitive information.
Data, privacy, and security are paramount.
We want these models to have enough data to be effective,
Right.
but we also need to safeguard people's privacy.
Exactly.
And that's why collaboration and dialogue are essential.
Couldn't agree more.
We need to work together.
To develop ethical guidelines.
It sounds like we're at a crucial point.
We are.
The potential benefits are huge.
But so are the risks.
It's up to all of us to ensure this technology is used for good.
I'm optimistic that by working together,
Yeah.
we can harness the power of AI
To create a better future.
for everyone.
Well, this has been an incredible deep dive. We've explored this research, discussed the potential impact.
And the ethical challenges.
Before we wrap up,
Yes.
let's recap some key takeaways.
Okay, here are a few.
Okay.
World models are AI systems that can learn and predict events.
Right?
GenieRedux and GenieRedux-G are two new models that leverage trained agents to learn efficiently.
Good.
Key metrics provide insights into these models' capabilities. Despite their promise, challenges remain.
Why-
Generalizability, data privacy.
Those are some great points to remember.
And for listeners who want to dive deeper,
Yes.
be sure to check the show notes.
And as always, we encourage you to keep exploring.
The fascinating world of AI.
Until next time, keep those minds curious.
And keep exploring.